just to make sure you understand it. We're going to talk about digital cameras. An electronics store sells about 70 of a new model of digital camera per month at a price of $320 each. For each $20 decrease in price, about 5 more cameras per month are sold. Write a function that models the situation, and then tell how the store can maximize monthly revenue from sales of the camera. So once again, we're going to use our revenue equation, our revenue formula. It's kind of like our verbal model. In this case, we do know that revenue is found by multiplying, in this case, our number of cameras that we sell times the cost of each camera. So in this case, I'm going to write it as a function. Revenue is a function of x. In x, this case, it could be a number of months. It could be a number of, in this case, we're going to decrease the price by 20 bucks. So it could be the number of price decreases. Really, there's a couple of different ways you could look at x in this problem that would be correct. I've seen it done a couple of different ways, but I'm just going to call it this time around a number of months. So I'm going to let x be my number of months. When I start the problem, we notice that we sell 70 cameras and that each of those cameras cost $320. That is a very nice camera. Now what's going to happen is that magical thing where if we knock money off of the original price of the item, we start to sell more and more of them. It's the whole sort of principle behind Black Friday or clearance sales. Like if you ever walk to the back of the store in the mall, they're just trying to liquidate as much merchandise as they can. So they'll sell it to you for anything. They knock so much off of the price, they just fly out the door. So in this is kind of the phenomenon we're exploring in this problem. So if I start to take money off of the price, I'm going to sell more cameras. Well, in this case, for every month that goes by, I'm going to sell 5 more cameras. So into the expression for the number of cameras, I'm going to change it. Not only am I going to sell the 70 to begin with, but I'm going to sell 5 more every month. More in math class means plus. And I'm going to sell 5 more every month. So after 1 month, I'll sell 5. After 2 months, I'll sell 10 more. After 3 months, I'll sell 15 more. So it's 5 times x. Now I have to go ahead and look at the expression for cost. In order to sell 5 every month, I had to decrease the price. To decrease means to subtract. So I'm going to take 320 and subtract $20 each month. So after 1 month, I knock $20 off the price. After 2 months, I'd be knocking $40 off the price. After 3 months, I'd be knocking $60 off the price. So I'm going to subtract 20x. Again, I'm asked to find the maximum. I have to maximize that revenue, and really the best way to figure out what that max is going to be when I'm given an equation in this form. I know it looks like intercept form, but it's not quite there. We're going to FOIL this problem, and we're going to write it in standard form. So if I FOIL this, I'd have negative 100x squared plus 200x plus 22,400. So again, whenever I'm asked to maximize something, I need to think max, and max is just a type of vertex. To find the max, or to find the vertex, we always have to find the x value first. So we have to do negative b over 2a. So in this case, that'll be negative 200 over 2 times negative 100. And that's just going to be 1. So really, I max out after just knocking 20 bucks off the price. So that's how we're going to go ahead and maximize that revenue. But we want to figure out what that revenue would be. So again, to do that, we're going to take that value of 1 right there, and we're going to go ahead and plug that into our revenue function. In other words, we're going to evaluate R at 1. So I'm going to go ahead, I just take my standard form. You can do it either way, and I've been doing it the other way before. I'm going to take that 1 and put it wherever I see an X. So plus 200x is now going to be plus 200 times 1, and then plus 22,400. And when you number crunch that, we actually get $22,500. Ooh, look at that. So we might write a sentence. We could say, the store can maximize revenue to $22,500 by decreasing the price by $20. Our new price is $300. So they'd have to sell the cameras for $300. Again, I always like to give you a way to verify this graphically. So I did take a moment to type the equation in standard form in my graphing calculator. So there is our equation in standard form, and you'll see in that screen there that I did hit, zoom 0 for zoom fit. So if I press graph, you see that whole beautiful parabola. And then if I'm trying to find the max, I need to find that top point right there. So I'm going to press second calc, option 4 for maximum. I'm going to go to the left of it, and we said we got to go to the left of 1 because that's what we were estimating. So, maybe 0 is to the left of 1, so I'll just go with that. That's our y-intercept. You see how our y-intercept is there? It's also in our equation, so that's cool. And then I'll go to the right, and I'll press enter to have it guess. And again, our calculators are stupid. It's not like they're doing the axis of symmetry formula. It uses the squeeze theorem from calculus. So we can just all of us can agree this is just 1. 1 comma 22,500 is your vertex there. And it also helps us verify the solution that we came up with some good old-fashioned algebra.